And we're back, and it's COMP392. That's Advanced Graphics for the Winter 2016 semester, and it's week 3, lesson 3, part 3, 333. So we just finished our little quiz, and it was kind of apparent that, you know, JavaScript still a weak spot for some people. I would say 40% of the people in here, right? So we're gonna have to do some more remedial JavaScript, you know, to kind of get you guys up to speed, because it's important. If you don't understand the language that we're using, later on, it's going to really come back to bite you all, right? So, so let's talk about a couple things. First of all, I want to run a little poll. I'm just going to come up and do my poll everywhere thing, right? And we'll create a new poll. That's neat to understand, just from a, and this is just from a thing. What ID are you using? Right? Are you using, as an example, Visual Studio 2013? I'll put, there's different versions, and there's some reasons that I got to put this in there. 2015, and here's another one, Visual Studio Code, right? And I'll put another something else like other. Please don't. I know someone's going to just answer other because, right, Stephen? But let's see what happens. Create your thing. I just wanted to understand, because it's important for me to understand the platforms. Okay, it's live at if you go to pollev.com/learn. Or if you text your response to text learn to 37607 other, come on, I knew someone was going to do that. That's just people playing with me, right? So mostly using Visual Studio Code. The reason why I'm asking this stuff is because I want to, I want to understand who's using what. And because it'll help me understand how I can gear the next piece that I want to talk about, some JavaScript, right? That's why I'm asking the question, not because I want to drive you all crazy, right? So again, I'm looking at, you know, lots of people use Visual Studio Code. So Visual Studio Code is good. That means that for the most part, we're all using Visual Studio Code. I would say there's some small amount of people, 20% of people right now, using Visual Studio in its different versions. Some people seem to be using something else. What other people? What are you guys all? What other stuff are you using? Huh? Oh yeah, sorry. Cloud9 would be the other one, and brackets, right? That's not bad. Cloud9. The reason I put other in there is because Cloud9 and brackets, there's some manual stuff you have to do to make TypeScript work, and/or create some automation. You can use some automation tools for that. That's why I'm asking you the question. So about 16% of people right now are responding and saying they're using Visual Studio 2013, 2015. Most people are using Visual Studio Code. Again, this would be the modern approach. I know it keeps changing because people are just, you know, going from different websites and messing me up, right? I'll stop the poll now. Thank you. It happens, you know, people are just on there, just like, let's just put as many responses as I can get, fill it up, right? Anyways, but the thing for me when I look at this kind of stuff is, even if it's 70% of you guys using Visual Studio Code, that's good. That's a good adoption rate. That means that you guys have listened, and you're using, you know, you're using Visual Studio Code. I'm telling you to use it, and hopefully that's what you do. You're not just telling me that you are. And the reason for that is because it applies to other technologies, right? So it's not just for Microsoft products. You can also use it for things like the Emerging Technologies course, this COMP392 course that we're doing at the same time with Professor Nika, right? He's doing that, and this is a great tool to use for that if you want to use that. Now he might be using Visual Studio for this, but Visual Studio Code is great for mean stack development. So that's one. The other thing I want to understand from this is, if you're using another tool like brackets, or if you're using something like Cloud9, that's cool. Cloud9 is a good tool, like I said, as a backup, or if, let's say, something you just can't make anything work, right, or whatever. Visual Studio Code is not working for you. Visual Studio 2013, 2015 is not working for you, so you're going to use something else. I think it's a good backup. But you need some automation, and let me talk about some automation. Gulp is a great module that you can download and install through NPM, right? And that'll help you automate some of your tasks when it comes to compiling. If you're using something like a brackets, or if you're using something like Cloud9, you can install Gulp. Let's talk about what this is for a second. Basically, you do the same thing that we normally do, npm install. It's an npm module. You install Gulp. And what you can do is you can use Gulp to watch certain files, right? The watch method of Gulp that's built into the Gulp API. And you watch certain files. So if they change, example, if my my TypeScript file changes, I can auto compile it to JavaScript. So I don't have to do Control-Shift-B. As soon as it changes, bam, it's going to go to TypeScript or going to go to JavaScript. That's pretty cool, right? So that means you don't have to be limited to just using Visual Studio Code. Visual Studio Code is cool because kind of the task runner is built in. What if you're limited and you can't use it and you want to use something like Cloud9? Gulp is a good option for that, for automation. And the other one is, it's a little older, but still works nicely as well. It takes a little bit more work to use in some ways. Grunt is the older technologies. Again, it's a task runner, and it allows us to, but you'd have to kind of, with Grunt, you'd have to kind of kick it off on the terminal. So you say, you actually run your Grunt, as an example, on the console, and then it would do all the compiling at the end. It's almost like pressing Control-Shift-B, but you do it on the console. It would do it for you. It doesn't have quite the watching methodology that Gulp does. Gulp, that's why I like Gulp a little better, and it's a little bit more modern to use Gulp. I'm not going to cover Gulp in this class because this isn't a, workflow, JavaScript workflow class. How to create workflows for your web projects. It's not about that. But I want to mention them to you because if you want to look and see how you can do that, if you really don't like Visual Studio Code and you want to use brackets as an example, or some other thing, Atom, some other code editor, Notepad++, whatever, right? You can do it, right? It just means that you're going to have to be more hands-on, and there's some automation you can do. So that's one thing. I just want to mention those two things, and I kind of mentioned it to a couple of people last day. Some challenges to work it out, but there's some really good tutorials. Like if I clicked on documentation for Gulp, which is the one I recommend, it tells you how to create your Gulp scenarios, if you will, and how to automate things and so on. And there's some really good tutorials online if you want to take a look at how to use Gulp. There's some pretty good documentation there. I'm not going to talk about it though. Okay, so that's one question. I'll come back to that polling stuff in a second because I'm going to ask you some more questions. So last day we talked about functions, or last week we talked about functions, TypeScript. We talked a little bit about classes. We created our class, the person class, and so on. And we talked some simple inheritance. We talked some, about the animal, how to, or whatever. An example of what we came up with is a person and a student, let's say, where you can inherit. This is kind of classical inheritance, the way we do things here. And we also briefly talked about modules. And I want to bring modules up again because modules are the kind of it's a topic of kind of confusion for some people, and I talked about a couple of steps to make modules. So notice how if I go to multi-file internal modules here on TypeScript on the actual on the website, it talks about what you need to do. So here's a module called validation.ts, which is just an external module TypeScript file. Notice how I'm exporting an interface. So these are the components you need. I need to have the module keyword in place, module, right? I need to name the module. Whatever the name that I choose is, think about that as the name of the namespace. So if I choose validation, then if I want to access string validator from outside of my module, I would have to say validation.string validator. That's the typical way to access my my interface, my class, my function, my whatever, constant, my variable, whatever I use the export keyword on. So export exposes anything that's in between these two braces, right? So again, when I create a module, remember what we did when we create a module. If I was going to go to, let's go to play for a second. So if I go to play, which means it's actually a playground for TypeScript. And I kind of did this before, but I'll do it again so you see the module. So we're going to create a module from scratch here. So let's say we use the module keyword, and then we say my module, right? My module, whatever my module is. Usually it's a namespace. Like I call it objects. And you'll see that a lot when I code stuff, right? So module, it's called objects, and then I have some curly braces, right? Well, notice on the right, there's nothing, right? And unless I put something in there, JavaScript doesn't really do anything with this, right? Even when I kind of translate this, right? I need to use the export keyword to export something. So let's talk about something like a variable. So variable, oh look, now it's getting something on the right. My variable, right? My variable, right? And let's say I assign it as a number. I type it as a number, and I assign it as 1, right? So my variable is the number value is 1, as an example. And this is what JavaScript gives you. Now, this should be a familiar pattern. We just talked about this today on the test. Look, it's an anonymous, self-executing function, right? That's what this is, and it stops here. From here to here, it's an anonymous self-executing function, right? Or an IFE, right? An immediately invoked function expression, which I'm going to say over and over again until you guys are like sick of me, right? So that's why it converts to. So it converts this nice pattern to this ugly pattern, right? I'm saying ugly because it's not as easy to understand. Notice what it's doing in JavaScript. It's saying var, I'm declaring a variable or a container. That's what I want you to think about variables as, called objects. Even though we're calling it module over here, we're just mentioning over here that it's just a container, right? And then what I'm doing is I'm saying, well, pass my objects into this anonymous self-executing function expression, right? That's what we're doing. We're passing it in there. And then my variable, right? My variable itself, I'm assigning it as 1. And notice on the way out, right? On the way out, I've got two things. I've got objects, right? Or, here's the or symbol. This symbol here is the or for most C style languages, right? Or also think about getting in some kind of objects that is equal to an object. Sorry to use objects as the method because that kind of confuses this. This is just an object literal. If I use two braces, that means it's an object, right? Once I assign it like this, it creates an instance. That's what it does. This is an empty instance object, empty object. Now, you don't have that in other languages, typically. You can't create an empty object. Like, it's empty. It's a container, and it's anonymous, and it's empty, and it's an object, and it's instantiated, right? No, it doesn't exist, right? But in JavaScript, yes, it does, right? And this is what it would look like. These two braces represent that object, right? So that's really what it does. Okay, so I noticed that, can I access my variable? If you looked at this function, and if you didn't know anything about this, could I access my variable right now outside of this closure? No, because there's nothing that returns anything outside of this closure. Once I put the export keyword in there, now you get something else, right? Now it says, let's attach my variable, right, to the object's variable, this namespace that's being passed in here, right? That's what happens. So as soon as I do this export keyword, now I have this structure, objects.myVariable, right? Because it takes the namespace that we've assigned, in this case objects, and adds, and this is how you would add a property, adds the myVariable property to it. That's what the structure looks like in JavaScript, which is a little cryptic if you've never seen it before. You're looking at it and going, I just don't understand that syntax. It's not natural. It's not intuitive for me to understand what that means. Where's my var, right? I want to see my var declaration over here, right? Yeah, no, it doesn't need a var. So that's one key. So I can do a variable. Let's put some spaces here. I can also do a constant, right? Constant, my constant. Right? And my constant usually be in by convention, my underscore constant, right, is a number which is equal to, let's say, 0, right? So it's the convention for us to use all caps with an underscore to separate key words, not like this. This is camel case. Typically, we do not use camel case with constants. As a convention, we use all caps separated by an underscore, like I said, right? So there's no difference here in JavaScript. We just add that container onto the object's namespace. That's what we're doing here. Okay, cool. And I can also do something like this. I can also export, my function, which is my function. I can do that too, right? And my function, of course, could have its own, variables. Var local variable, right, which is a number. Sorry, I'm boring you. I know, which is equal to 3. And as I'm just making 1, 2, 3, or 1, make it 2, just to make it interesting, right? So there's some. I can also export my function. Now look what it does with this one. It kind of creates a function here within a function, which also encrypts what's going on here. Kind of look at it and you're like, wait a minute, how come I'm declaring a function within a function? It's totally possible in JavaScript. And you might see several layers, function within a function within a function within a function. You're going to see that a lot in JavaScript. which is really bad, right? We don't want that. But also, you can export all these types. So now I can see that when I use my function, I can say objects.myfunction. I can access it that way. And look, it actually does it here. So when it compiles, TypeScript converts to, it says, hey, let's create an alias, objects.myfunction, which is a variable. Remember we talked about the anonymous function methodology, right, or pattern, right? Well, there it is. I have a my function, a name function, and all I'm doing is creating an alias for this name function to create that structure that looks like this. That's all I'm doing. This is the trick that we're using here to make it so that it seems that my function is a function that belongs to this namespace. Okay, I could also do a class. So export class, and now I can do really crazy stuff like my class. And now this is a much more complicated structure. Notice how I can do it all, by the way. All these things are legal in my namespace, right? So I can keep going in here. I can say something like, well, I have some private instance variables. I want you to try this out so you can see what I'm talking about here, right? My private instance variables, I'm going to have, you know, I can use the private keyword for classes, right? Private, protected, and public. Those are the keywords I can use for as access modifiers. So private, and I can call it, you know, my private variable, whatever that is. In this example, which is, let's say we'll make it a number, which is equal to 3. We can do that, or we can just make it a number here. Hold on a second, that's the proper way to do it. And we can have a constructor, right? And the constructor also might take in some kind of variable. We'll call it another variable, which is also a number. And what we're going to say here is that this, you know, my variable, my private variable, we're using this keyword to refer to the private variable that's inside this class, right, is equal to another variable that comes into, you know, to this class, into this constructor function, right? So here's our constructor. Notice how it becomes much more challenging here, and what it's doing here. So this is my little class. It doesn't have a method. Let's add a method too. We'll make it a public. You know, my class method. There we go. And the method does something like a console.log. Hey, right? It just says hey whenever you invoke that particular method. So take a look at what it's doing here. It's kind of trying to figure out how to do my class. So again, here's a function. Here's a function right here, which is inside this function, which is a closure, right? And here's another closure. Look at, there's another closure that it does within my closure. So what does this mean? Well, my class on its own actually is its own namespace, if you think about it, right? So I've got kind of like, for me to access my class's objects, I got to use my objects first, which is the namespace itself, as the first accessor. And then I'm going to use the .accessor method to access objects of my class, right? So my class, the name of the class itself. And then if I want to access the function, which is my class, right? My function, my class, right? Notice how there's two. There's the external piece here, which is the self-executing anonymous function. And then there's an internal one in here, right? Plus, there's something that we use in this ugly prototype methodology to create it as well, right? So as you can see, you can get quite complex, right, to write something that's a lot more human readable on the left side. And I'm not trying to sell you TypeScript. I think I've sold it to most of you, right? It's not that. It's understanding when I use a module, right, what I'm actually doing. I'm exposing, you know, these different containers, right? These different container types. Here's the class, right? And notice how I still make an alias at the bottom. This alias objects.myClass is equal to the myClass namespace and class, if you will, right? That's what I'm doing here, right? Now, there's also other things like interfaces, and I can keep going. So why would I ever do this? A question for the class. Why would I ever have a variable that's inside my module that's separate from, let's say, something like a class? Would there be a need for that? And think about the use. Chances are I wouldn't, right? You could, but I could use these kind of things to create something like if I want to make some kind of configuration file, and I always want to use it. Like for example, like I did it already. If I have a config file that always does things like, instead of it calculating my screen width, if I know my screen size is going to be 640 by 480, why do I want my program to calculate that all the time? If I know it's everything I'm doing here in my program, 640 by 480. That's what it's going to be, right? If I know that, I should create constants, right? And refer to these constants as human readable, code, whatever, instead of putting in a hard-coded number like 640 by 480, or even doing a calculation like, creating an aspect variable and saying, width over height or something like that. That's not cool, right? That's a calculation. I want to reduce calculations. And so I can create object modules, as an example, that give me the ability to export things just like variables and constants. Sometimes I want to create a module, I want to make a closure, and I want to make a utility method or function that's available to all my classes, or even in the global space, right? But I want to partition it because I don't want to clutter up my main file. Like I might have a main file like game.ts or app.ts, whatever, and I want to have a function that I made, right? Somewhere that it's acceptable to this file and other files as well. But I don't want to necessarily make a class, right? I don't want to instantiate an object. So there's a couple ways I can do that. One, I can create a static class, right, with a method that I use, right, with no constructor function. I can do that, right? That's one. Or the other way is just making a function in JavaScript and including it here and exporting it, just like I do here in this module. So this is another method to do that. So you don't have to actually create a class all the time. This is more like functional, programming as opposed to classical programming. But you could still do this. That's why you can mix different programming styles when we're using TypeScript and JavaScript. Okay, cool. I'm just pointing this out. So this is the first piece. The first piece is you make your module. You have to use the module keyword. I need to use the export keyword to export or expose anything I want inside the module. If I take one of these away, now watch what happens. If I take away this export keyword from my function, look how it affects it, right? It takes away that alias. So now my function is only available at module level. So my function has a module level scope. It doesn't go outside of this module. Okay, cool. That's kind of cool. That means I can do some, almost like a private function that's available to this class if I wanted to, or whatever, for whatever reason, almost creating its own little program. I can make my own little program here with its own scope and everything else inside this closure, this module, right? So that's another reason why I might want to do it. So I need to use the module keyword and the export keyword. Those are the two things I need. Okay, number one, I talked about this before. Part two, if I was to go back to, if I go to Learn Handbook, that's where I'm getting all this stuff, right? And if I go back to modules, and if I go back to splitting across files, which is what I'm using right now, that's one piece, but I need to include a couple things. A reference path, and you've seen this before. So in the module, another module or another file that I'm using, I'm including this module in another external file. I need to make a reference to it. I need to use the // That's the notation that I need. So // and then I need to use the words in angled brackets, reference path equals to, and the path of the module, the local path to your module. And usually what you want to do is you want to make it so that it's relative path. You don't want to make it so it's specific, C:\\. You don't want to do that, because that'll be just work for your computer. You want to use the relative path, way of noting it, which is ... go up a level and so on, and to mention the path, relative path, right? So that's what you want to do, and you want to specify this as a reference. So I need that piece. If I don't have that piece, I can't reference in this module more often than not. Okay, it might work, may not. You want to do that. So what we're saying here is this: I'm including this module validation, and I'm making a reference path to it again. Here's something to note. Once I use the same name twice, if I use module objects, and I do it again in another file, module objects, I can use that same module over and over again. What am I really doing when I do that? When I use the same module name over and over again. So I've got a module name, it's called objects. And I use it again in another file, and in another file, and in another file. What am I doing? Well, I'm extending the module. That's what I'm doing. I like that. I can extend my namespace by just using the same module name over and over again. And that means that if I use objects as a module name, and I use this a lot, by the way, you'll see in my patterns, right? That means if it's inside the module, it can reference itself without using the objects prefix, right? Because it's inside the same module. So as long as it's inside the same module, I can access classes, I can access whatever without using the module name as a prefix. I can do that. I really don't have to do this. In practice, I never do this. I never reference, the previous module declaration within the same module name. So it's all the same module name. So I don't really do this. And then in modern TypeScript, we don't do that. I've never seen anyone do this kind of stuff. You don't need to. As long as you do this reference path in the main document, right? And you include that in the main document inside, in our case, inside our underscore reference.ts file, right? It's available to all other modules that are connected to it. Okay, so that's one thing to note. Another piece is I need to include this stuff. If I don't have, I need something to tie everything together. And it's my index.html. And here's an example of this. And this is an excerpt from an index.html. Notice how validation would have been an object, a module that's added, that's attached to our manifest, if you will. I don't have if I don't have the index.html, and if I don't include a script reference to the actual module, it's not included. Even if you refer to it, and even if you use the same module name, it won't work because you haven't included it inside index.html. It's required, and it's required not just for this mod, not for what we're doing here with Three.js, but for Create.js, for AngularJS, for jQuery, for whatever you're doing. Right? You need to include it inside your index.html. That's the one proviso, if you will, if you're using front-end technologies. Back-end technologies, you can use the require keyword if you're using something like Node.js, right, to require that module, and so you don't have to have an index.html. But for front-end technologies, you need to do that. Sometimes we need to include an external module that's not our own. And when we did that, we used this type definition library, and that's why we want to use TSD. Our type definition libraries describe the classes that belong to somebody else. And a lot of times those classes that belong to somebody else, those classes and structures, they're written in vanilla JavaScript, right? So we use a type definition file, and notice how on the bottom it says writing type definition files here, how to do that. Well, we use the declare keyword to declare a class or a variable that belongs to a vanilla JavaScript class. All we're doing is we're not actually defining it. Think about it almost as creating an interface, right? Our type definition libraries are just interfaces to point to existing structures. Like, for example, I have, I don't know, Supergirl over here writes she writes a JavaScript file, right, in another class, and she wants to reuse it, right? But it was written in JavaScript, not in TypeScript, and I want to use it in my code, right? I can create a type definition library, right, that describes your vanilla JavaScript module, and I can bring it into my code with all the type hinting and everything else, and describe its types and everything else that I'm expecting. Okay, so I can do that, which is cool. That's really, really cool. That's why we use type definition libraries. Okay, let's do a little example before I bore the crap out of everybody here, right? Because I know that you guys are falling asleep when I'm talking. Yes.
So what exactly is a module? Like, how would you define it?
Think about it as its own file or its own container, right? Yeah. If I want to split across different files, like we do in C# or Java, right? It's another file, right? And I can partition it. And usually what I do as a convention, I don't have to do this. I usually use a folder to put it inside of. So example, let's say if I want to make a module, a namespace called objects, I make an objects folder. And inside my objects folder, I have a file that's called whatever the module is I'm making. Example would be if I'm making a person class or person object, right? It's going to be in my objects folder, and it's going to be called person. So that's going to be my person object. It has to, you want to kind of name it so that it reflects. If I read it and it says, here's an object, I got a person object. Okay, I understand. This is what I'm creating here, a person object. The module naming is key to understanding what kind of object, function, whatever I'm using, whatever it means, right? Otherwise, you don't want to be too cryptic because you can be as cryptic as you want. I want to call module XYZ, and my object is called ABC. So and actually to access my object ABC, I got to go xyz.abc, which is really cryptic. It's like, what the hell is going on here? You don't want that. If I see that in code, that means like either someone's really trying to be cryptic or they don't know what they're doing, right? So that's what a module. Module is like a container that contains a piece of code. I split my code up. If I have a big piece of code, thousands of lines of code, right? Why would I want that? I want to make it, I want to be able to eat that elephant, right? So I'm going to chunk it down. I'm going to make the code smaller so I can see it. And anything that's outside of about a page or two, I want to put it into a module, all right? Because if it's so big that I got to scroll through 5, 6 pages to see, there might be an opportunity for me to create, put this into another module. The other part of the other methodology is I usually split very different classes into different modules, right? So, example, I have a namespace like objects, and I have a bunch of classes that I want to use in that namespace. I take a bunch of classes. Each class is going to have their own file, and usually the class name is going to be the file name, and it's going to be inside a folder. That's going to be the name of the module, and that's how I'm going to organize my code, right? From an organizational perspective, not because I need to, but because I want to, so I can simplify what I'm looking at. Because as I get bigger and as I create an enterprise level application, it's going to come to the point where it's unmanageable. It's unmanageable. I'm going to have a huge piece of code, everything in one, right? And you see some JavaScript does that, right? And then you're like, okay, so where do I start? How do I modify this? But if I split it over files, right, I can reuse some of those files in another project, right? Yeah.
And it's good. So model itself is kind of quite similar to package in Java or to
Yes. Yes. That's exactly what I want you to relate it to a Java package. Now you have to format it that way. And in my way, I format it that way. You don't have to format it. You just call it, you just name it in your file. But that's a little bit loose for me, right? For me, when I call up the module, it has to be in a folder, just as a convention for me, right? So it's a package. Okay. Let's make an example happen. Okay, so let's pull up a Visual Studio Code here. Here's my Visual Studio Code, and I'm going to bring up a kind of the thing that we were working on last day, right? To kind of split across this. I want to talk about this. So remember last day we were working on this thing that was COMP392. We did a 3JS boilerplate, and we also did this other one called Lesson 3 Demo, right? Lesson 3 Demo is the one that I was really working on with you, so I'm going to pull that into Visual Studio Code here. And I already have a module that I snuck in there. Actually, there's a couple, right? So let's talk about these ones, right? Under scripts, inside the objects folder, inside my scripts folder, actually I have a couple folders, one called core and the other one called objects, right? Inside objects, I have two main TS files. Actually, there's three. There's a control.ts, here's that module keyword, and there's objects, right? Notice how it's empty. There's nothing in here. This one, remember, I kind of put this as a container that we can use to create our control, the control that pops up on the right corner of our screen, right? That's what I've created this. I've also created a game object, right? And a game object is actually a mesh. It extends. I use the extends keyword for the class to extend a 3JS mesh object. That's what I'm doing. And I'm extending the functionality by requiring a geometry and material and then X, Y, and Z. That's all I've done here. There's nothing different about this. But I've also said, let's turn on by default for my objects, all game objects by default, the one I made, they all have receive shadows and cast shadows is on, right? Otherwise, I'd have to kind of position this every single time I made an object, like for example, a sphere or a cube or whatever. I have to always say receive shadow is true and cast shadow is true. I'd have to say those things explicitly. It's not automatic, right? So I've created a little object here that does it. Notice it's also part of the objects namespace. Here's one more. Here's point. Point is also part of the objects namespace, and it's a point class that basically contains three properties, if you will, three instance variables, X, Y, and Z, right? And then what I can do is I can set up this little object of X, Y, and Z. In fact, if anything, this is like a vector3 object, right? In other languages, right? So I have an object that has three properties, right? X, Y, and Z. And then in the constructor function, I can set these properties. I haven't created getters and setters, but by the way, I can in TypeScript, right? Yes, because I said public. Correct. So it wouldn't be point, whatever the name of the object I created, through the point class. So let's say, for example, I created, point 1 or P1. P1 is equal to a new point, and I pass in X, Y, and Z coordinates for the point, right? 0, 0, 0, let's say, as a default, right? I could do that. And if I say X, Y, and Z as default points, as an example, then if I say P1.x, P1.y, and P1.z would be available to me as an object, right? Okay, let's make another one. I want to make some kind of configuration file, but I want to make another namespace. So what would I do here if I wanted to make another namespace with a configuration file that holds my width and the height of my screen? Okay, so how would I do that? First thing first, what would I do first? New folder, right? So if I want to make a new namespace, by convention, I'm not telling you have to do this. By convention, I would make a new folder to kind of describe my namespace, right? Where I'm going to contain or partition all the files related to it. That's all I'm doing here. I'm just creating an organizational structure, not because I have to. So new folder under scripts. So on scripts, if you're following me here, I'm using the COMP392 lesson 3 demo file here, right? So I'm going to right click on scripts and I'm going to add a new folder. And the new folder that I'm going to call, let's call it the config module, right? So config, here we are, enter. There's my folder name. Now I have nothing in there right now. There's nothing in config, right? I need a file and I need some kind of object that I'm going to export from that file in the module, right? So I just can't have a config module. So I want to call it like my screen config, right? If I think about my screen config, hey, that's probably a good name for the file, screen.ts, right? So let's do that. So right click, I want to put a new file. And let's call this thing screen.ts. It's a TypeScript file that we haven't transpiled yet, okay? I need to put the keyword module in here. And then I need to put the name of the module, and I'm probably going to call it config, right? Because the name of the folder. Here's my folder, config, module name, config. And then I need to put curly braces to kind of encapsulate that module, create the container, right? That's what it does. Okay, cool. Now, I'm going to call some constants, right? And I want to export them. That's all they're going to do. So I'm going to say export, and I'm going to have the constant keyword, and the constant that I'm going to export is width in caps, right? And I'm going to make it a number, and I'm going to assign it as a default, and I'm just going to put it out there for you, to 640, because that's kind of a width that we can find to fit. We can make it other ones too. Let's do the same thing. I'll say export const height, right? And then it'll be number, and that'll be equal to 480, let's just say, right? It's a small screen, by the way. Cool, that's our module, right? We have a module. It's inside of a folder. We've named the folder and the module the same name. That's kind of a convention we're using to organize things. My module is called, my actual module itself, like the actual object we have, is called screen, right? I'm never going to see my screen config. I'm just going to go config dot and then width, config dot height. How do I further branch off if I was going to do that in a module? Because there isn't. I could make a class, my screen class, right? And I could make it, if I really wanted to, I could make it that it's a static class, right? With no constructor. Let's see how to do that. So let's keep those ideas down here. We'll keep these things down here, but I want to make a class. So I have a class that I'm going to call screen, right? My screen class. And again, I use the braces to kind of compartmentalize the screen class. I don't need a constructor, right? That doesn't make any sense. But I want to make this screen class static, right? A static class, or want to make these things static, right? How do I do that? Well, let's take these things, cut them, and put them over here, right? And now I got some problems in here. Notice how I can't export specifically members of a class. I need to export the class itself. So here's export. But I don't want to, I never want to, notice how I have constants in here, right? Const height. Notice how it says duplicate identifier const, right? Because const is what we're doing here is it's in a class situation, it's a constant, but I gotta think about something else. Can I use the word static? Can I use that word? If I make it static, and can I use this word static? That's the word that I want to use in a class, right? So I export my class, I use the keyword static in here, and now I don't have to instantiate this class, right? By the way, you can interpose the class name with an interface if you wanted to. It'd be the same, right? So instead of calling it a class, you can make an interface. So now it's screen width. So I'm hoping that I could do something like this. I can say my screen dot width. If I went down here inside my module, I can do something like screen, right, dot width, and it would come up. See how that comes up? If it comes up here in the module, how do I access it outside the module? Well, it would be config screen dot width. That's how it would look outside of the module, if that's what we want. And I'll fix that in a second. Okay, so let's do that. So I got my screen width, and this all the modules can do. Do I have a constructor function? No, because I'm never going to instantiate my class. I'm using these static keywords. And by the way, if you want to see the documentation for this, if I look at static, if I want to try and find static in this whole thing here, so let's just look for it. File. I start looking at static. My static side, I want to see the static stuff. What does it do? It says an example. Here's an example of where I want to use the static side of the class, right? And I can have a class A with a static, some kind of static container, right? And or I can have part of my class has a constructor, right? But there might be a piece that never needs to be instantiated. That's a part of every object, right? Shared, if you will, right? So note there is an opportunity for us to use static classes, but when we transpile, it's going to look a little different, right? Than it would normally look for a class. And I just wanted to show you that too. So let's go back. So again, so we use the static keyword to access this object right here, and it's going to be a static class. I could have left the class piece out and left the constant in there, but I wanted to demonstrate what this does. Okay, so I save it. I want to transpile, right? Let's see what it gives us. It gives us this JavaScript file that looks like this. What is this, right? It's an empty function. There's my empty constructor, and there's a function. There's a closure within a closure. That's all I'm doing, and I'm compartmentalizing. So if you notice, I say config.screen is equal to screen, and what I could do, notice how screen width. It already has done this. I have access to the screen width property and screen height property. So I've created, in my way, couple of static variables, or constants, if you will, right, that are created, right? Okay, cool. How do I access these things? So in my index.html, second step, I want to do this next. And normally, you can use one of the other two steps second. Where would I put this? Is it dependent on anything? Will my objects, my point or my control object or my game object depend on my config? Maybe. So I probably want to put it before everything else. If I'm making configuration files or some kind of control files, whatever, I want to put them as early as I can. Definitely under my JavaScript libraries, but before every other script. So I'm going to kind of put it in here. So I'm going to say script, and we're going to make a source. We're going to use the source attribute to assign the scripts. We're going to go scripts, and instead of objects, I'm going to go config, and then in there I'm going to say screen.js, right? Because it's going to be transpiled. That's how I include it. So I've included it in my manifest. I want to call my index.html my manifest, the thing that kind of ties all my JavaScript stuff together, right? Cool. Next piece. I need to make a reference to it somewhere, and I'm going to do that. Remember, inside of my scripts, under my core, I have a reference file that I created called reference.ts. I'm probably going to put it underneath my typings and before my other objects. Let's do that. So I'm going to go // and I'll say reference path, and I'll type this in is equal to, and again, I'm going to go up one, across the config, down into screen.ts, and close it off. And if I've done it, if I've actually typed it properly, if it's the correct path, it won't give me an error. If it's a false path, if I made a mistake, it'll give me an error saying, can't find this file. That's good, right? So I've made a reference to it here, yeah. It's identical when I transpile. Here, I'll show you. If I transpile, right, once I do that, my reference.js is identical. It's just a container for me to reference. It's a reference of a reference, right? So I don't have to include a bunch of references in my main game.ts file. I only have one. And that reference file references everything else. Otherwise, I'm going to have a pile of references when I do my big application, like a ton of them at the top of my file, which is a pain in the ass. And we've seen that when we make games. It can get quite large. If I have many, many pieces, many, many objects in my game, it can get crazy, right? So I don't want that, and I compartmentalize those into a separate file called reference.ts. That's what I'm doing here. Okay, cool. So I've already done that. Everything is connected, and I want to use it. But look, I have these import statements. These import statements are optional. If I use an import statement, what I can actually do is create an alias for that particular namespace. So I could do something like this. At the bottom, let's say underneath the point, I could do something like this. I can say import, right? I want to call this screen, capital S for screen, is equal to what? Config.screen, which means now, right? And it's going to give me an error for a second. I want to show you this, right? Notice how it says import declaration conflicts with local declaration of screen. Yeah, because I have something else somewhere. There might be a local declaration of screen, as an example, right? In 3JS, I might have that, right? And that's where, you know, might have an issue in this particular case, because I might have somewhere else that I've kind of mentioned what the screen is, right? There might be a local thing, but just to be sure, sometimes that's not true. It's just TypeScript. If I transpile, right, it might go away. The error might go away. If it doesn't go away, that means somewhere in 3JS, as an example, it's got, yeah, there's probably some kind of screen prototype that's taken over, right? That's kind of a problem. So that may not work, but I could always rename it something like config screen, you know, something like that. I can name it whatever I want. I'm just to show you that. I just want to show you the renaming, so you see how I can alias it if I really want to, or I just can call it, you know, I can call it whatever I want, but maybe I'll call it C screen, config screen, right? Something easy. So instead of config.screen, right? If I use C screen, now if I go back down to the bottom where you notice I have my camera has an aspect, right? And so does my on resize. It's my window inner width divided by my window inner height. And I told you this is a calculation that we're doing here, right? So instead of doing this, right, and I'm just going to go back down here to my config, right? Notice how my setup camera is window inner width divided by window inner height and so on. I don't have to do that. Let's make a copy of this. So we're going to kind of, you know, cram this out for a second and make some more space for you guys to see this. I'm going to take this whole thing. Let's see what happens if I take my camera and instead of window inner width and window inner height, that's my aspect ratio, right? I want to make a calculation, but I want to use my screen width and screen height. I don't know. So here's my CS, so screen, right? So so config screen, if I can spell it properly, dot width, I can do that, right? Divided by, I can use those things, config screen dot height. That's not a great example, but I could do that. That's my ratio. But what's my ratio? What's 640 by 480? Just saying. 640 divided by 480. What's the solution for that? Let's check it. Just so for people who haven't seen it, someone's going to take out my calculator here, and we're going to do the calculation for us, right? So here's my calculator, and if I take 640, right, and divide it by 480, right, I'm going to get a number, 1.33333, right? That's the number. That's the ratio that I'm using, right? Why would I make that calculation if it's always going to be the same? So let's go back, right? Let's go back to my files. And let's go back to my config, right? And inside my screen.ts, I'm going to have another thing called static, right? Which I'm going to call ratio, right? And it's going to be a number. And I'm going to assign it approximately to 1.33333, something like that. Right? Something that's, you know, long enough so that it's long, you know, fairly long number. And it's going to be using this ratio instead of the screen ratio. Okay, cool. So I save that, my transpile. I go back to my game.ts, and instead of doing this calculation now, I don't have to even do this anymore. I'm just going to go cscreen.ratio, right? And that's what's going to go in here instead of what it is. And so if you don't know what this is, you can always go to my config.screen.ratio. I can always type that in too if I really want to, instead of cscreen. Even though I've made a shortcut, I can always go config.screen.ratio, right? For whatever it is. Right? I can do that too. So both will work. Okay, cool. That's okay, but I may have used inner width and inner height somewhere else, right? So window inner height, this is the set size when I do my render. And in here, I probably want to do the same thing. So just so I don't mess up, I'm gonna copy this line and paste it, and I'm just going to comment it out. So my inner width is width. So I'm going to say, you know, cscreen width. Right, and it's going to make the screen look a little different, by the way, guys. And cscreen, because I'm going to limit it to 640 by 480, dot height, right? So there it is. So cscreen dot width and height. Right, there it is. That's my changes, right? And you know what? I have a resize function that I probably want to use too, right? So my camera aspect, well, that's easy. I'm just going to make it so that it's the aspect, right? So cscreen. So first of all, let's copy this line, right? copy the line, and go in here and paste it, and we're going to just comment this out so we can always go back, which we will. And I want to, this is just an example, I want to say cscreen dot aspect or ratio. There we go. That's what it is, right? So you get that. And the same thing goes here. Window width and height, it would be cscreen dot width and cscreen dot height. Why would I want to do that? Why would I just accept the window width and height? Is there a reason why I would ever want to do this? Anybody? Specific devices. If I want to fit on 320 by 480 specifically, or if I want to make sure that my maximum screen size is 640 by 480, no matter what happens, right? Then I want to, or if I always want to have 640 by 480, I never want, even when you resize or reset, it's always going to be that screen size. By the way, this resize function will not work, right? Just FYI, right? Because it's going to, I've set it to, it's never going to resize now. It's always going to be 640 by 480. I've broken it, right? And you know what? Just because I did, I should probably copy this once for a second. Sorry. Otherwise, we're not going to be. We're going to forget, and we're going to leave it this way. I'm just typing it so you can see the differences, how to use this kind of thing. I'm going. It's a long example, but I want you to understand it because, you know, so you understand how you can do this for your own code, which is kind of cool. Okay, so we're using a static class, if you will, to export this stuff. I don't think I missed it anywhere else. I may have. Let's check out other things. Let me check out some other stuff just in case. So in my core, I'm good. Let's go to my objects. So control objects, I'm good. Let's go to my game.ts. There's nothing in here that tells me, or my game object, which doesn't really show me anything here either. This is kind of cool. The same thing with my point. There's nothing to do with screen there. Okay, let's transpile and see if it works, this thing, right? And see what it gives. Let's see if it gives us 640 by 480, right? Let's test it out. So how do I do this? So I'm going to go here, and then we'll pause for a break. So here I'm going to go to Reveal in Finder, right? And here's my lesson 3 demo, and I'm going to double click on my index.html, and hey, there's 640 by 480 for you, right? Notice how it is exactly 640 by 480, right? As opposed to the screen height and width. So if I want to make, so if that's the case, I can make I can accommodate my screen so it fits in a specific window, right? And this is how we would make something like this work for us for another application. Like for example, I don't want my visualization to take up the whole screen. I want to only be at 640 by 480, right? Somewhere. I can pop it in somewhere, right? Well, this is how I would do it, right? Now notice there's no controls. I have my control here, but there's no controls because I don't have a control class that I've defined, right, for this particular thing. Questions on what we did? Anybody? So all I did was I created an example namespace called config, right? And then I created an inner class, a screen class that we're never going to instantiate. We're never going to make an object of that class. It's just a static class. We can access its static members, right? Our static members would be, we made 3 of them. We made a ratio, we made a width and a height. And the reason why we don't want to calculate the ratio, especially if we have a lot of iterations, especially in some kind of game loop, is lots of calculations, right? If I have to calculate all the time, why? Why would I calculate something that's going to always be the same, right? If I know it's 640 by 480, put in the ratio, and you're going to be fine. Okay, let's take a 5-minute break, and we'll come back and do some 3JS, all right?